Good morning, good afternoon, depending on where you coming in to us, depending on where you're signing in from today. I'd like to thank everyone for joining us. Today, the past data science chapter is providing a presentation today on introduction to ML and .NET. But before we get into that presentation and introduce the speaker, we want to kind of handle some basic housekeeping. So first announcement is that Rohan Kumar will be a keynote speaker for day one of PAS Virtual Summit, which is coming up. PAS Virtual Summit is also bringing back the Women in Technology keynote speaker and also introducing the diversity, equality, and inclusion keynotes at this year's event. You can find more information either using the QR code or the link. PAS Passion Award nominations are now open, and those nominations are open now until October the 15th. So if anyone wants to nominate anyone, feel free to go ahead and do that as well. We also want to announce that the Board of Director election applications will be opening up next week, starting on Monday, and that will be open until October the 9th. So if anyone wants to nominate someone for the board of directors, feel free to do that. Link is in the slide deck as well. There's also a chance to get a complimentary ebook from Bob Ward. Um, this is this is for the first 1,500 pass registrants. So if anyone is interested in signed up, you guys can get you a copy of that ebook. Pass is also adding an additional membership option, which is a pro membership, which is going to allow for some greater and stronger learning within the community and more networking opportunities. So we ask anyone who's interested in this to please look into this. And there's also some fun coming up for everyone, which is the Database Cup. If anyone is interested in a little Jeopardy style competition, please look into this. It's sure to be some fun. The speaker idol 2020 is here, so you can enter for a chance to actually win a speaking spot at next year's PASS Summit. So if anyone is looking into getting into speaking and want to kind of get on the big stage, this is a great opportunity to do that. And we also want to talk about some of the upcoming webinars that the PAS community is putting out. Um, there's some, of course, there are different virtual groups that will be hosting these, and there's a complete list that's in the deck. So if anyone is interested in learning about what events are coming up, feel free to check that out. And as always, our upcoming SQL Saturdays. So this is a list of all of the SQL Saturdays that are scheduled for the from now until October. So if anyone is interested in attending any of these SQL Saturdays, feel free to go ahead and register. And as we know, PASS is a big community, and there's a lot of virtual groups that are still doing a lot of the great work that they've always done, both in person and virtually. So here's a list of the virtual groups that are out there if anyone is interested in signing up for some new groups or learning more about any of the groups that are out there. Past Career Center. If anyone is looking for a new opportunity or looking to change existing positions, please go ahead and check out the Past Career Center. There's a lot of there's job postings and that you can actually apply for there. And as always, continue to connect with Pass. There's a lot of different ways that you can go about staying connected via social media, Facebook, Twitter, LinkedIn, Instagram, and of course Pass TV with the YouTube series. And with that, I would like to go ahead and turn the session over to our presenter today, who is Mark Tabladillo, who will be presenting a topic on introductions to ML and .NET, ML.NET.
All right, thanks, Tawan. And so glad to be here presenting today. I'm going to switch to presentation mode, and let me go to the correct screen. Okay, let's do that. And I think this will go. You should be able to see my deck. I think it's showing now.
Yes.
Okay, sounds good. So Tawan will be here, and if you have any questions during the talk, go ahead and type them into the questions box, and I will be answering those questions toward the end. But we have an exciting topic here today, Introduction to ML.NET. This is completely open source technology. And for those of you who've worked with .NET in Microsoft, you remember a time when Microsoft had provided the direction, and this was really before open source really took on as a concept. But with the growth of so many languages in the .NET ecosystem, Microsoft decided to turn all its technology over to .NET. And just giving an introduction for myself, I am a cloud solution architect at Microsoft, and my day-to-day job supporting our national team is to work with our customers in bringing their solutions to Azure, which is one of Microsoft's clouds. It's really our main cloud. And then we also have some other clouds, delivering things like, Dynamics and other service offerings. But ML.NET is completely open source. You can use it now. It'll work in Windows, Linux, and many other systems. And as we'll see, it has a lot of great features that are of interest to data scientists. I work with a lot of data science projects, and this is one of our key technologies, especially if you are a .NET developer or have a .NET solution that you're already supporting. You would want to look at this seriously. It is being used in several of our Microsoft products, and one of the things that happened is that our product managers were monitoring my Twitter feed, and so they found out I was going to be talking about this topic. So as it turns out, just by total coincidence, there is another ML.NET presentation that happens just at the same time when this one ends. And I provided a link there, but I also put it into the chat area. So if you go to that chat, it's going to be on YouTube. And if you click, normally when you click to YouTube, you go to a video. But this one, it just shows that there's going to be a presentation starting in about an hour. So if you want to either watch that live or save it for later, there's going to be a specific ML presentation following this one, and it's going to be on a specific topic. One of my friends, Bart, is going to be doing that presentation, and Bart and I have worked together. We both supported an open hack that we had at Cornell University in Ithaca, New York. So I know him from that, and he's also at Microsoft. So another interesting topic if you're interested in doing that. But let's focus for today. We have 6 sections in this presentation: state of .NET, what is ML.NET, who are some of the usage and customers, and then a demo, and then we'll go into architecture and then action. So we'll give you some things to do. Everything I'm showing today, by the way, in terms of demos, are demos that are already available, but I'm going to point to the ones that I think are excellent in highlighting the key features of ML.NET. So let's start here with .NET. There are some metrics that Microsoft has to be able to track that. Now, Microsoft can do that, when people log on, but there's an estimate now, 4 million plus engaged 2-day developers. And when it says 2 days, I'm thinking it's either 2 days a week or 2 days a month. But anyway, it's the most important thing is just the raw number that Microsoft knows that there's an engagement by that many developers. And then in 2019, there were additional 750,000 new developers added. And of course, people fall off, but people are still adopting .NET as a platform for development. And there's a high affinity Azure, so you don't have to use Azure to be using .NET, but we know that 80% of the .NET developers are on a paid SKU of Visual Studio are also using Azure. So that is important, and also .NET is a great place to do a lot of Azure development. So this .NET can be used for doing a lot of different things, and you see on the left, starting here with desktop, and then going to web, cloud, mobile, gaming, IoT, ML. Now these can be independent. You know, you don't have to do cloud just because you're doing desktop. But what we're here to talk about today is what can you do with ML, and how could you blend ML with any one of these options on the left side. Inside the ML.NET is something called TLC. Now, this is the old name for the project, and this is how we inside Microsoft knew the project before it became ML.NET. So MSR, meaning Microsoft Research, developed what they called the learning code to enable developers to add ML to Microsoft products and technologies. And it's been reused internally for the past 9 or so years to add ML to features in major products, such as what? Windows Hello, Bing Ads, PowerPoint design ideas, etc. I know myself personally, you may have seen the PowerPoint design ideas technology, but that's something I use when I'm making slides. But then, you know, it's also behind the scenes for other projects at Microsoft. In May 2018, Microsoft made the API publicly available, open source, and cross-platform. And at Build meaning the name of a conference, they released the first preview of ML.NET. So that is, it is open source and it is cross-platform. So when we say cross-platform, we mean it can be used on Windows, Linux, or Mac OS for development, and then be delivered in all the modalities I had showed earlier, which could be IoT, which could be Azure, which could be desktop. Some of the scenarios that are supported here on the left side, classical, we have things like classification. These are the tasks on the left, and then the example scenarios are like use cases. So classification could be used for topic categorization. Regression could be used to predict the car price. Anomaly detection could be used for credit card fraud. And in fact, what is on the right side here are examples of things that people typically do with machine learning. And also important to show is also that this ML.NET will also support deep learning. And there's an example in here that works with TensorFlow. It is built for all .NET developers. So people who are doing .NET can use existing C# and F# skills to integrate ML into .NET apps. F# is not a language many people use. However, if you are writing algorithms, especially for machine learning, I definitely would recommend you look into writing them in F# rather than C#. And you can make a solution with both C# and F# together. That is not a problem. But there are some programming efficiencies with F# which might make it an appealing language for people who are doing some intermediate to advanced machine learning or deep learning. But just for ML.NET, there's no initial data science or ML experience required. Now, I do say, even when you say there's no experience required, you do need to learn the terminology, such as we had on the previous slide, and what some of the terms mean, so that you can understand the documentation and even how to communicate the results of your work. Tools and features to help developers easily build, train, and deploy high-quality custom ML models. So that's the whole thing here. Is the goal of machine learning is to make these models, and the models are functions. So the functions run inside apps, and the whole end game of building these models is to build these functions. And this is for local and Azure deployment. And notice that in the product team, the goal is not to convert Python or R developers to .NET, but instead to target 100% of .NET developers and enable them to add ML to their .NET apps. So there are many, and it's not just about the developers. I'm going to go, I know I bumped that slide here. It's not just focusing on the developers, but many developers have already created some sophisticated solutions and some, advanced software where there's already a big investment in .NET. And so Microsoft wanted to have a story for those projects and examples. And it started with the ones I showed earlier, some of the examples where Microsoft's already investing in its own ecosystem. So why not share the love? The same type of technology that Microsoft's used to put into its own products is made available through this for any .NET developers, and especially when there's a large code base. As you may have seen me present on data science previously, I believe people that make data science a career are going to need to learn multiple languages. Not that you have to master every possible language, but that you have some amount of knowledge and comfort level should someone give you something that's written in another language. So it's about enabling of .NET developers, and we're not trying to compete with TensorFlow or PyTorch. In fact, that's instead of rewriting that, that was made integrated in an integrated way, so you can integrate TensorFlow into the solution. So this is not targeting data scientists in the sense that the MLnet.NET tool set is really intended more for the development cycle, software development cycle. On this second point, we would say, well, what does target data scientists? Right now, Azure Machine Learning is the primary technology that targets data scientists. That's for someone who just wants to start with their team some sort of new investigation. But right now, we know that there are 5 million plus developers who have an affinity to Azure. And for that group, this is the technology that Microsoft's recommending to look at first into integrating machine learning. Now, to be successful, okay, you can't just have a solution and say, okay, we're going to code classification into .NET, but it's got to be comparable. Okay, so let's talk about the comparability here. This is a performance study that was done in May of 2019, and then there's an archive paper that supports the claims on this slide. But ML.NET outperformed other frameworks in experimental evaluation of performance with both two things. On the left side here, higher accuracy, and the right side, lower runtime. And in their tests that they did, in the configuration they were using, scikit-learn and H2O through overflow and memory errors when training with a full 9 GB data set. So if you want to look at those results, you can see, now I know you look at the size of the bars. I mean, obviously 85, this is, 85. If we started at 0, 0 would be way down over here. But it is true that ML.NET had a higher accuracy based on this study, and then also in runtime, doing it in fewer minutes. And why? Because they're just taking advantage of the efficiencies, and the development of TLC over a period of years led them team at Microsoft Research to write something that performs really well and with high accuracy. So this is the key statement, that ML.NET is not just something interesting to use, but also, especially for .NET developer, might work as well or faster than other competitive technologies. These are not the only two dimensions that people are thinking about when they're thinking about competitive machine learning frameworks, but it is important to at least study this at the beginning when someone's developing this type of technology. Here's some of the momentum. And in 2019, it was at version 1, 2020, version 1.5. And these numbers I got from GitHub. So how many people it started, how many forked it, commits, contributors. There's been an uptick, and we can see, also information here on the languages being used. So a lot of people are actually using C# for ML.NET. It's predominant. Okay, usage. What's it being used for? TLC, again, is the name of the old technology. It's functionally identical to ML.NET, and Microsoft's now working with internal teams to move from this to ML.NET as they have time, because these are some large projects. But being add predictions, Excel charts, PowerPoint design ideas, dynamics fraud detection. And then we have inside ML.NET, we've got Azure AutoML, Azure Stream Analytics, anomaly detection. And then inside Microsoft Defender, there's something called antivirus threat protection. And inside Power BI, there's something called AI visuals, key influencers. So as we're going forward, and especially with new projects at Microsoft, new teams are really landing here at ML.NET rather than the previous version of TLC. These are some of the external companies that are using ML.NET, and a lot of these are listed on the website. And then there's some customer examples that are online. And of course, these slides are going to be available after presentation. So if you want to look at who's using it and how they're using it, you can take a look at that. So let's go to a demo. And I am going to show my screen. Let me end this and let me rearrange my icons here to show my screen. I think I'm also going to show a different screen. I'm going to show screen 1 because it's got a different resolution.
Hey, Mark, while we're transitioning, we have a couple of questions come in. Did you want to wait till the end, or did you want to take those now?
Let's see. Do we have, I see a question there. Do you have numbers against Onyx? Okay, so let me explain how to understand Onyx. So Onyx is really neural network exchange. It's really, I view it as more of an output format rather than a training framework. So Onyx is where things can land as far as runtime performance and fast. So I guess the question might be though, what would happen if you made it developed a model in scikit-learn and then translated it to Onyx format and ran on the Onyx runtime? And in those cases, the runtime would be really fast. As just as a comment in general, and I have not done this with ML.NET. ML.NET, of course, is going to have its own runtime, and then there's a separate type of Onyx runtime. And so if you look at the use case here, this is not just running a raw model, but it's going to run a model inside a .NET app. So it's got a certain use case to run the whole thing together. And then the case of just an Onyx runtime, when it's scoring for a model, and it might be deployed, for example, in Azure Kubernetes service, that is the way that I recommend people develop their models. Why? Because the Onyx runtime is often faster than any other way of doing it, sometimes 2 and 3x. So going back to the architecture question, it's going to depend what the use case is for that type of output. But to my knowledge, I don't know that anyone has studied that for the dimension of runtime. We still have to go consider both dimensions because it's not just about the speed of the output, but also the claim of the accuracy. So if you want to, but that's a great question. So thanks for asking that. Okay. I am looking at Visual Studio, and we're Visual Studio 2019. And what I've opened here is solutions. It's called Solution 1.4 All Samples. And let me give some orientation. Where did this come from? So here's the ML.NET open source cross-platform. So this is the website. And on here, it talks about built for .NET developers. And now on the bottom here, we're beginning to see examples of applications and use cases. So here, I mean, sentiment analysis, product recommendation, price prediction, these are some of the things that are common in data science, and the link here goes to GitHub. So here in machine learning samples, here's where I grabbed the demo that I'm going to show in Visual Studio. They continue to work on this. I mean, I noticed that this was last updated 15 days ago. I know that I grabbed my copy before that. So what I'm working with is a little older than what's on here, but you can see you can go here and code and then just click down here to either clone or download the zip file. So you can just go get this code yourself and then run it. And you see the categories here. So what's inside the samples? They give some binary classifications. They give them in multiple languages. Again, I like the fact that they gave a lot of these in F#, because again, it might not seem efficient to learn a new language or to use a language that you haven't heard much about. But if you are in the .NET world, you do need to take a serious look at why they're using F# for this purpose. So it's really efficient for running the type of or writing the type of functions that are important in machine learning. Multi-class classifications, the second category here. So we got several examples on that. Several examples for regression, one-time series example, some for anomaly detection and clustering, and computer vision. This is one of the examples here of deep learning. And then cross-cutting scenarios. So they made some other examples here, and also some automate.ml.nets. This is preview. One thing I always caution with preview is, at least for my clients, I try not to put them in a preview of anything unless they are very experimental, because what happens is APIs may change and you don't want to put something into production and then assume that there will be no API changes or that you're not going to have to go back and fix something. So just a caution about putting things that are preview. Now, AutoML itself is not preview. It's actually generally available. But what they are claiming here is that this connector is still in a preview state. Okay, now I'm going to go to here, and you can see inside this, I opened the one that's C#, and in the top here they have some getting started samples, and I'll just close that folder, and then end-to-end apps. And on the bottom here, they have examples of some projects you can do. And I am going to do, there's some in here that I have run, and for some reason they don't run for me, but I don't try to overthink it, because the projects, the solutions actually are under current revision, and you always have to make sure that your local environment matches the environment that's on the web. So that being said, let's just go to one of them here. I'm going to go to the sentiment analysis one. I'm going to go to server and hit the button. So these are already written. So for a .NET developer, what you know is that you can go into the solution and see all the code that was made to write this app. I am not really a great developer. I am an okay developer, but I'm not really a great developer. And I certainly don't do any web or mobile development. So what this does is this will do live sentiment based on here, and it's going to change the box. So, and again, you know, this technology has a certain amount of accuracy. I just typed in a sentence that came to my mind, and I didn't even prep that sentence. So I'm surprised that it has such a positive sentiment here associated with those words. But it was trained, And now it's showing that the results are now being shown into the demo app. Now I'm going to give you all a chance to participate. So if you want to type in either the chat or the questions area some sort of sentence, and I will put that into the box, and I'll do maybe like 3. So first 3 to type in something into the question area, or I guess you can put it in the chat. I see a hand raise, and let's see if we can get to you. Where's the link? Someone's asking where's the link. It's going to be in the questions area on the right side, but it says questions. I'll have to show maybe in the interface. I don't know. I don't know if I can find it quickly. Sorry. Tuan, we'll have to do that in the future. Make sure we show people how to get to the. But I see I love chocolate, so let's try that. I love chocolate.
Yeah, we have a few other ones as well.
97, so you beat me. Okay, all right, so I already got enough here. So let's try a few of these. I'm gonna kill this pizza, I'm so hungry, is 84%. Oh, actually, Steve, when you asked where's the link, that was the questions box, so you're good. Oh, actually, you might be referring to where's the link for the next seminar. That's in the chat window. Yes, that's in the chat window. You should be able to see that there. And I think this question was intended to be part of our sentiment, so I'm going to try that. Will Gilead's vaccine be effective? And of course, sentiment is just describing plus and minus on a scale. It's not trying to evaluate, validity of an answer or anything, but it's just giving you an idea there. Okay. I see some other questions there that I'll get to later from George and others, so I will get to that later. So that gives you an idea of what that is. Let me drill in a little bit just to show you what is being provided here in terms of solution. So if you go in here, there isn't actually a program here, and you go into the ML area and you see the data models, the ML sentiment model.zip, that was part of what is part of the solution. And then there was a client. So there's different parts of this solution. I'm not going to go into all the different parts because some of these are kind of complex, and it's also going to add things like dependencies, which have to do with specifically what's needed to run the different solutions. But you can see some of the things that are in there for that. And let me go into this one. ASP.NET Core. And again, I'm not a .NET developer, so I couldn't tell you what a lot of these things are, but here's what I do know. When it says Microsoft ML, we're talking about the ML .NET technology right there. And then some of these other things can be added. And if you are a .NET person, you can add, whatever other technologies that you're using inside .NET to make a solution. Okay, I'm going to run another one that I know works for me, and the TensorFlow image classification. And again, this one down here, this one is one that's integrated with TensorFlow, and then it has the app here that works with that. And hopefully it remembers my directory, otherwise I'm going to have to navigate back. Oh no, I put in the pictures. I remember where I put it. So let's give it a second for the web app to start. Okay. One thing I like to see is these little diagnostic tools. It shows how my memory and CPU are being used, while I'm running something. Right now, it's not using a lot of the CPU, for example. Let's go back to the image. Choose a file. And this is going to be very simple. So it's just going to take a file. And I think it's only really 2 things that it does. It just chooses whether or not it's the high office chair or the green office chair. These are the ones that they gave. It's not intended to be a demonstration of how to best use machine learning. Rather, the example is intended to be a demonstration of the technology. In other words, to show how to integrate TensorFlow into the entire story. But that was the high office chair. And then the other one is the green office chair. Upload, and it does a prediction. So this is an example of a web app doing a prediction of a model that was trained. And if I go back to, let me see if I go back to here and find that one. I think it's this one. No, that's not what I want. Let's see, go there. Okay. So on the website, they give more information on all the examples. I'm not sure if this is the exact one that I showed, but let's read this one. And this one has to do with image classification, and it'll probably work through transfer learning, although I don't see that yet. But it'll explain here the process of doing the training. And transfer learning is when you use most of the network except for the last layer, where it gets retrained based on images that are introduced. Like here in this data set, it was introducing this set of images. Because this doesn't match one I just saw, I don't think this is the one I did. I think it's this one maybe. And I don't know. No, that's not it either. Okay, but these still are examples inside the computer vision section. So if you're doing a problem like that, you can use it for that use case. Let me describe some of the projects that I've seen in the wild for doing image classification or computer vision. One was a manufacturing example, and they were making these rolls. And I think these rolls were like plastic or some sort of polymer fiber. And what they wanted to do was be able to take pictures of the roll from the end, meaning the circular end. So it's like a cylinder, but if you take a picture of the circle side, you may be able to see or notice some flaws that happen during the manufacturing process. So what they wanted to use computer vision for was to be able to take pictures of these rolls and assist the people that were doing manual inspection to be able to see if there were flaws during the manufacturing process. As you might imagine, in a manufacturing facility, there might be hundreds or thousands of these rolls being produced. And while it is important to have people there to be doing physical inspection of these rolls, and these are like big rolls. When I say big, I'm talking like 4 and 5 feet high. So huge commercial industrial project where they're taking, and they were already taking photographs of these images and doing inspection. A second one was also an inspection example, and I had several customers bring up this use case, and that was inspection of commercial buildings. So on many commercial buildings, they use drones to be able to take pictures around the building and do regular inspection, just for maintenance and also insurance purposes. So for that purpose, people have to study those photographs and look for potential flaws or issues that might happen. So again, it's another use case where there's a lot of money involved, potentially, in terms of risk reward. And then for doing the inspection, yes, you have to have people doing it, but it also helps to have a corpus of images already pre-trained to see whether or not there's an issue there. And several customers have already come up with that idea. So those are some of the examples of what people might do with computer vision. I like to share those because sometimes, a lot of these other areas like recommendation and classification, there's so many examples that are available in machine learning. And it seems like we're still early on understanding real world applications of deep learning. Okay, now so I'm not going to focus more on this. There's a lot of samples that you can look at for yourself in here. And I'm going to instead migrate to the next section of my talk, and that will be doing a tutorial. So this is a tutorial. We can get started in 10 minutes. And in fact, you could just go in and play the video, and the video will get you started because it's going to be exactly the same thing I'm about to say. But this takes about 10 minutes to get started, and I'm already ready. So you need to have Visual Studio 2019, this version or later, for this example. Now I have Visual Studio because Microsoft gives me Visual Studio, and you would have it if you're a .NET developer. Okay, so don't see that as a barrier, as far as using a technology. There's a technology called Model Builder. Model Builder is like a wizard, and it is in the Visual Studio ecosystems called an extension. So it's an extension, something is added into the environment. I think I might just show the screen here instead of actually doing it because I see we're a bit tight on time. But what you do is you go inside, you enable Model Builder. Then here, and in fact, this is an animated image here. So it's showing how to add that, add there, and that's going to go to machine learning. And then that will add it to a solution. So once it's in there inside Visual Studio, you can add the extension into a solution. Then you start it, and you go in here, and it's going to ask, what do you want to do? Do you want to do text classification, value prediction, image classification? One of these things, and then it's going to help you. It's going to get started. So the reason this is important, it's not that this model builder is going to make your whole solution for you, but what it does is it helps the .NET developer get started, either just at least understanding how the technology works, if not B, being a good start toward something that can be integrated into an actual solution. So somewhere between there is a use case for why would someone want to use Model Builder. In the example here, they ask you to choose the first one here, text classification. So there's a specific data set, and I've already downloaded this, but I'm not going to do it for right now. I'm just going to skip through this because I would rather show the slides. But you go in here and you add the files, and then it shows you the sentiment, either positive or negative. Again, this is a binary classifier. And then you're going to go through and train, and this is going to show the training process. And right here, I guess on the training, they're saying find the best model in 10 seconds or something like that. So it's just going to, find one and then make that available. Then for doing evaluation, you can try the model out and do a prediction based on the model and see if that does match. And then here, generate code. In the code step, select add projects. Model Builder adds both the machine learning model and the projects for training and consuming the model to your solution. So in Solution Explorer, you should see the code files that were generated. So because there's a number of things that are generated here, the use case for the Model Builder, again, is to provide some understanding on how to do it without having you to say, oh, make this first thing, make the second thing, add this, add that. Instead of having that, you do that. The Model Builder will give a head start with something that already works. And then consuming the model here is, just some process of doing that. So new model input, that's root. Okay, here, this consume model dot predict input, and then it comes back as a result, and then write what the result is. So here, this is being able to use by calling the particular area of code, the function. And then you can run it here. And a lot of the examples, they use console just to be able to simplify, interactivity. So that's why a lot of them are written in console. I know the examples I showed earlier with web apps, I think that shows better for just a demo. But if you're actually going to work on this, you're probably going to want to send things to and from console while you're getting the process started. Then at that point, decide whether or not it stays there or it gets bundled into some sort of function or delivered, like for example, into a web app. So then there's more examples. So that is what's possible. And they have actually a second example here with the taxi fare data set. So it says try out the value prediction scenario, price prediction, with this sample data set. So they got two things to do. But let me go back to the slides as we're coming to the end, and also I see we have some questions. So let me change, actually, I'm gonna stop sharing on screen 1, and we're gonna go back to screen 2. So hold on a second. And hopefully we should be where I left off. We are. Okay. So model builders for that, it's a simple UI, it's a Visual Studio extension, and it generates code. And I think that to me is the main thing. I know if I were working with a developer, I would definitely recommend that for real world projects and for working with Azure right now. So some of the largest clients we have, definitely recommending that's the path they go down, at least you're getting started. These are some of the local AutoML trainings. And then, so some of the training can happen either locally or on Azure. And so these are some of the ones that can do local AutoML training, and these are some of the ones that can do Azure AutoML training. So that's the description there of options. And this is, they're planning to actually bundle this into Visual Studio, and it might already be there, I don't know. So if it is there, that means you don't have to add it as an extension, it's just gonna be there. Command line interface is important, especially for initial development. So that does work with Mac OS or Windows. Okay, so here's more of the description of the data set. So there's 4 pillars here. First of all, it's the data. It's represented as iData view, so that you can load data from files or from database. And the data transform will convert data into a format acceptable for ML algorithms. That's important because wherever it's coming from needs to have a way to work with the .NET environment. So here is where the value of this technology is. It's taking files from wherever they are, which might be, you know, those locations, and then it's making it possible to put it into the ML ecosystem. Then we have the training. And the training was, again, similar to what I showed in an earlier slide. These are all the TLC algorithms, the ones that perform with high accuracy. The accuracy comes from the algorithm writing. The speed would come from, you know, the entire ecosystem. So the model consumption and evaluation there. So trained model, prediction engine. By the way, we had a question on Onyx. There is an Onyx export to export whatever ML.NET produces to Onyx. So it's a little more complicated than thinking of them as competitive. Something that's developed here could be put into Onyx. So, you know, again, it's going to be depending on architecture, whether one wants to run that in Onyx or not. And then there's evaluators for each ML task. Okay, so you can see some of the evaluators that are available. You have to look in the documentation though. This is again an overview, and I would, you know, if you're serious about looking at details, you're gonna have to read the documentation. So the extensions and tools enables more ML scenarios and investigating PyTorch. So actually PyTorch is under investigation, it's not fully integrated into yet. It can consume pre-trained Onyx and TensorFlow models. So again, on Onyx, not only produce them, but also consume them. So that's a good thing for people who are writing maybe in another language and you want to produce Onyx, then bring it here, put it into this framework, and then run it with your .NET project. But I would definitely, even if you're doing development somewhere else like scikit-learn, and then you land in Onyx and you have .NET, I would do it to Onyx and then I would bring it here. Okay, so it's not either or trying to make a competition, but you see this is a very open source technology. It's intended really to work with a lot of things. I learned, you can run .NET with Jupyter Notebooks. I don't do that, but it's possible. Okay, so all right, and then there's some links here about getting started, the samples, the docs, and requesting features. Okay, so let me get to the questions here, and I can see the questions on the screen. So Tuan, I'll go ahead and do that. And Tuan's been answering questions. I can see that on our monitor panel. So thanks for doing that. Okay, here's one question. Azure Machine Learning is very good. What does this add to that? Okay, what this adds is being able to do the entire thing just in the Visual Studio environment. That might be a local environment, or that might be embedding into an application. So if I were working with, let's say we had both. If I were working with both, I actually like Azure Machine Learning better for development, just of the model. But when you saw some of the examples that I had with the web app, that's only possible if you have a full development environment. So in that case, what I would consider doing is doing the development in Azure Machine Learning, and then maybe bringing Onyx model or something back to the ML.NET environment to be consumed and also integrated into some sort of solution, which might be something like a web app. Okay, and when will ML.NET come to Azure Machine Learning? Well, you could, I don't know how to answer that because TLC algorithms, I know Microsoft put some algorithms into the designer, and I'm not sure if they are the same or not. Actually, I don't know the answer to that. They might be the same, but there's an area of Azure Machine Learning called the designer where you drag and drop widgets onto an interface, and I believe they are the same, but I don't know that as a fact. So, but I believe they are the same. Will it be fully integrated? Will AML, for example, become a software development environment? I doubt that. So there's always going to be some piece of this that, this technology was really meant to complement and extend Visual Studio. And like I said, the 4 million, 5 million developers that are out there already using Visual Studio day to day. So, that is a certain ecosystem. And then, another thing is that these technologies don't have to be completely, independent. But I know if I were working with a client, one of the things I do as an architect, we often talk about what are the different modalities for delivering machine learning. And it doesn't have to be competition. It might be the answer is blended. So meaning that some projects will make more sense to either develop and or deliver in something like Azure Machine Learning. Same thing with ML.NET. Some things might be better to develop and or extend there. The way to know perhaps is to try. And that's, my day-to-day job is often running trials because we don't actually know the answer. We have a sense, but we can take off a small piece of the puzzle and test it out, look at it both ways, and then evaluate it maybe perhaps by multiple dimensions of features and usability, and then decide what should go one way and what should go another. And again, we're talking about cases of enterprise software development where we may have multiple projects. Okay. Are there any noteworthy packages in ML.NET for materials or chemistry? The ones that are in here are really oriented toward, let me click the documentation link. I'm going to end the slideshow, but let me click the documentation link. It'll come up on the other screen. Hang on a second. The ones that let's see, Is this correct? Before I show it, I think this is correct. I think it's correct. I keep seeing a Microsoft Ignite at the time. I'm wondering, why is this up here? Well, it's up here because this is running right now. There's a conference called Microsoft Ignite, which you can go watch if you want. It's on now. But here's the MLNet.net documentation. If you look at the algorithms inside here, they tend to be very generic. So it's going to be things like binary classification, and you can see the names of them. So these are the names of the trainers that are available. And then multi-class trainers, and then they've given them names either related to where they've come from in open source or how they're being applied. And then here's some for regression. I would not tag any of these as being specific to any type of application, such as materials or chemistry, but you're thinking more about the functions, about what do they do. Like here's 2 here for ranking. And so all these algorithms have a specific application. And going back to the top here, there's 2 ways to understand applying them. One, I gave a link early on who's using it in a generic sense. That's going to be very high level use case. The second thing, it would be just to go looking for your example. Like if you were looking for applying machine learning for some sort of chemistry or chemical science. And by the way, I'm working with one of our major chemical customers right now on a project where they're doing some upgrading, and they're coming from the desktop into the Azure environment. But most of their work is either going to be custom algorithm or it's going to be something that is just an application of something that's already here. If you're doing a custom app, again, if I'm saying you're writing it from scratch, I would look at F#. But generally, I would answer the question by going and seeing what similar people are doing in industry, and then seeing if one of these use cases matches. How well does it match? That would be my approach. Okay. I'm going down the screen again. All right, well, okay, I'm going down. Can you jump to the training section? I want to see how this, okay, so actually he's offline now. Okay. Does ML.NET have topic modeling capability? I think the answer to that is no. So topic modeling is something that I think is covered in the corpus of natural language processing algorithms that I see more commonly used, for example, in Python. Now, we do have, in the cognitive services, text analytics, I would look at what we have in the text analytics. This is a service. Okay, so you give it something and then it gives you information back. But the text analytics has ability to take out sentiment, entities, and key phrases. I was using it yesterday with one of the new features we have, which is PII, personally identifiable information. So inside the service, they have the ability to pull out PII from a text example. So that is not exactly on topic with the topic modeling, but this is what I would look at. And of course, anything right here, these are going to focus on classical machine learning. So it's not, you don't see a lot of natural language processing here. And me personally, I probably would try to do that either with Python or looking at like a service like text analytics. Okay, let me see here, and I know we're running close to time. All right, what I meant is like an SDK. Oh, okay. Can you jump to the training section? Okay. Well, there's not a good comparison here with Azure Machine Learning. A lot of what happens in this technology is very rudimentary. In other words, one difference with Azure Machine Learning is Azure Machine Learning has an entire workspace. So everything's organized. It's organizing your models, it's organizing your model deployment, it's enabling people perhaps to work together, collaborate, share compute, and then you have compute instances and clusters that you can spin up to be able to train models. That's not true here. ML.NET is a raw programming play. It is all about software. So there's nothing in ML.NET really that implies hardware. And that's why that's one of the things that makes it different from Azure Machine Learning, which is really an environment intended to bundle data science development with being able to specify hardware. So that's one of the differences. So ML.NET, you do need to bring your own hardware. That definitely is true. But you can see here, and what I would recommend as far as follow-up, for people who are serious about this, I always want them to go to concepts. We always have, I think pretty much now Microsoft has concepts in all our products. Me personally, this is where I learn because I want to understand how it works. And then me personally, then I go to something that's like tutorials. And then I try to do some project building. But for me to first understand, especially the metrics, and I think it's, for people who've had experience as a data scientist, what you probably want to do is start definitely with the concepts, because you do not need to learn, if you're a data scientist, what is AUC, because you've seen AUC. And you already know, the closer to one, the better. I know this document says it, but you already know that. But what's important in reading the concepts is just how does what you already know about data science map into ML.NET? Okay, we are a bit over time, so I'm going to go back to Terrell for any kind of final comments.
Well, thank you, Mark. So I wanted to go ahead and wrap up. We want to go ahead and thank Mark again for his time and his wonderful presentation. I think that you did answer the last question. We're 2 minutes over, so I think we could go ahead and end this meeting. So once again, thank everyone for joining us, and see you next time.